Okay, number 7. Describe the transformation and shifts of the quadratic function in comparison to the parent function. Okay, so for our first one, our number outside of our parentheses out here at the end tells me whether it goes up or down, and it follows exactly what it says there. So this is going to go down 6 units, and my plus 4, since it's inside parentheses, it's the opposite. So it goes left 4 units. Okay, B here does not shift left or right since it's just x squared, but this plus 10 is like outside, it's not in parentheses, so that's just going to go up 10 units. Okay, C again, I have inside and I have outside, so not in parentheses. This right here tells me that it goes down 1 unit, and inside is minus 1. So remember, if it's inside the parentheses, it's the opposite, so it shifts to the right 1 unit. Okay. 8, describe the transformation and shifts of the absolute value function in comparison to the parent function. Okay, so this is going to be the same thing here. Outside tells me that it's going to go up 2 units. The negative 3 tells me that it's going to go right, the opposite. The absolute value works just like parentheses in this. Right 3 units. Okay, and the 4 on the outside tells me that it's going to be narrow. Okay, B, again, it's going to go down 8. This tells me that it's going to go left 1. And that half, since that number is less than 1, it's a fraction, that's going to be wider. Okay, C, this tells me outside up 1. There's nothing inside, so it doesn't move left or right, but this is going to make it more narrow. Okay, 9, what is the slope intercept form of the following equation? Alright, so I need to change this to y equals mx plus b. Okay, so I'm going to start off by distributing. Y plus 8 equals 3x plus 6. Then I'm going to subtract 8 from both sides and get y equals 3x minus 2. Okay, over here I'm going to do the same thing. I'm going to distribute. Y plus 10 equals 2x plus 12. And then I'm going to subtract 10 from both sides. So y equals 2x plus 2. Okay, 10 says write an equation in slope-intercept form given the following point and slope for each line. Okay, so this is 6, 0, alright, so that doesn't help me at all write this equation. I need to start in point slope form, which is y minus y1 equals m x minus x1. So let's go ahead and, this is x1, y1. So y minus 0 equals negative 3, x minus negative 6. Okay, so since that's minus and negative, I'm going to change that to a plus, and then I'm going to go ahead and distribute. Since this is y minus 0, I'm just going to drop that because it doesn't do anything. So y equals negative 3x minus 18. Okay, my next one is going to be the same. Y minus y1 equals m x minus x1. So y minus 0 equals negative 2 x minus 10. So y equals negative 2x plus 20. Okay, 11 tells me to find the slope of the line that goes through the following sets of points. So remember, slope equals y2 minus y1 over x2 minus x1. That's rise over run. Okay, so I'm going to go ahead and plug in 5 minus 3 over 6 minus negative 2. So that's going to change to a plus. So I get 2 over 8, which equals 1/4. Okay, same thing over here. y2 minus y1 over x2 minus x1. This changes to a plus, get negative 1 over 3. Okay, for 12, it says state the slope of the line in the following graphs. So for these, I want to look for really nice points. Okay, most of these on this graph happen to be nice points, so I can pick just about any point I want, and then I'm going to count rise, negative 1 over 1. So the slope equals negative 1 over 1, which equals negative 1. Okay, over here I see my graph doesn't go through as many nice points, so I want to pick a nice point that it goes through, like this point and this one. Then I'm going to count rise over run, so down 2, right 3. So m equals negative 2 over 3.